let's start. We're going to start on a new chapter, elasticity. Again, for those who are watching online, I'll try to go slowly. I'll try to speak through all that I write on the whiteboard. If it's a little unclear, I hope you can listen to what I'm trying to say. Let's have this example, where we look at the demand for, let's say, rice or bread. If we're looking at the example in Taiwan, maybe we can talk about rice. For many other non-Asian countries, perhaps bread. Basically, I'm trying to think of a product of which people buy the most. That is staple food. Right? Not the most, but the most commonly. Okay. And let's have a look at the demand for rice. Perhaps something like this as a demand for rice. And let's say the price changes. Okay, the price changes. The price increases from, let's say, 50 NT per kilo. Okay, the price is going to increase by a whole, I don't know, 60%. So the price is going to jump up all the way up to 80 NT per kilo. Okay, so let's say that at the price of 50 NT per kilo, let's say that 120 kilos, let's say that 120 kilos used to be bought. I don't know, maybe it's some village within Taiwan or a village in Indonesia where people eat rice, or a village in Malaysia, whatever. Okay. Now the price is now the rice is much more expensive. It's 80 NT per kilo. It's 60% higher. Right? Do you think people are going to stop eating rice? If we are looking at a small village in Malaysia, right? Rice is a staple food. People don't eat as much bread. Everybody eats rice with almost every meal, right? People don't eat as many potatoes. People don't eat as much other carbs as rice, right? The price has increased from 50 NT to 80 NT per kilo. Are people going to stop eating rice? How do you think? No, it's their staple food, right? Maybe they will try to cut down on some amount of rice they eat. Maybe sometimes instead of buying rice, they will have sweet potatoes, right? Or whatever not, but still they're going to eat mostly rice. So the quantity consumed, this is quantity demanded, right? Because it's the same demand curve. So the demand didn't change. We only moved from one point to the next, from point A to point B. So what's changing is only the quantity demanded. Let's say it's down to 100, right? So what can we say about this demand, and what can we say about the quantity demanded as it reacts to price changes? The reactions are not very elastic. It's just staying in mostly the same place, right? Right? So if you pull a rubber band, it can stretch quite far. Whereas here, the changes in quantity as a reaction to the change in price is quite small. It's not elastic. It doesn't go far. Right? So this will be our example for, it's called inelastic demand. Okay, where quantities don't really change that much, wherever other price changes. Let's have a look at another example. I wonder if there is a nice marker that makes visible lines, visible on the videos. Let's see. So we have price, quantities, and let's say this is let's say we are still in that same village in the outskirts of Tainan, somewhere in the middle of Taiwan, right? We're still in Asia, but now we're looking at the demand for, I don't know, let's say German sausages, right? A particular product. Perhaps some people eat German sausages, perhaps sometimes, right? So let's have a look at the demand. Maybe looking something like this, demand function, demand curve, right? And let's have the same percentage change in price. It will be fair enough to have a percentage change that is the same. So let's start with a price of, what did I have in my notes? Let's start with a price of $100. So $100 per kilo. Clearly, maybe German sausages are more expensive than rice, I don't know. And let's say the same 60% increase in price. Let's see what happens to how much of those sausages people eat. So let's increase that price to $160. So in that village, maybe weekly consumption or monthly consumption of those German sausages used to be around 120 kilos previously at a lower price. But now that the price is increased to 160, instead of eating German sausages, I guess most people are just going to eat pork, right? Raw pork, cooked, I mean, not in the form of sausages. Buy chicken, buy beef, buy goat, whatever, lamb, right? So if this particular product of German sausages becomes 60% higher, almost nobody's going to buy it. So let's say the quantity demanded decreases by quite a lot. From 50, let's say all the way down to 60, or 50. From what? Anyway, you see the numbers. From 120 originally, let's say, all the way down to 50. Okay. So perhaps there are some German engineers working in that village and they must have that sausage. I don't know. Who is buying it? So what we see here is more of elasticity in how demand quantity responds to price change. We see that price change now changes more of a stretch, right? Changes the quantity demanded by more. The movement is further. It's like more elastic. You don't really need to think about this kind of rubber band or whatever. I'm just trying to make some visual impressions to connect with the topic, the title of the chapter, so things are easy for you to kind of understand and also remember. Yes? But basically, right, we see that we have two different examples. In one example, a 60% change in price results in almost no change in quantity demanded. In another example, the same 60% change in price results in a big change in quantity demanded. So clearly there's something different about these two demand curves. And we want to be able to measure this something. We're going to call it elasticity. Okay? And elasticity of demand, okay? Measures how so it's very difficult to read here. The markers are not great, and perhaps the video quality might be not good enough for you to read. So elasticity of demand measures how responsive changes, I'll use triangle for changes, in quantity demanded, how responsive changes in quantity demanded are to changes in price. Okay, so elasticity of demand measures how responsive changes in quantity demanded are to changes in price. So I'm going to use it as PED, price elasticity of demand, because we'll also talk about other types of elasticities, but that's for next week. Right? Because there will be other types of elasticities, I'll just call it particularly PED, price elasticity of demand, which is the percentage change in quantity demanded over the percentage change in price. Okay.
How much of a difference must there be for it to be considered elasticity?
Very good question. Yes, absolutely. So we are going to cover that. So that is a good question, meaning that we must go there. Yes. I just want to take things step by step. So let me finish with this, and we're going to go there. We're going to go there. So let's have a look at these particular examples. Right? We have, in the first example of rice and bread, rice, a 60% change in price, and only small percentage change in quantity. Right? So in our first example, the denominator is bigger than the numerator. Right? Okay, so if denominator is bigger than the numerator, the whole thing is generally less than 1 if I ignore the sign, right? Because small number divided by big number, we have something that is less than 1. Right? If I ignore the negative sign, because there's actually a negative sign, we'll have a look at that once we actually do kind of more detailed calculation. For now, let's just have a look at which side is bigger. Upper side, which is the numerator, yes, or the lower side, which is the denominator. In the second example of German sausages, the percentage change in quantity is very big. Over here we have like a more than a very big percentage change. I'm not sure what it is, right? Whereas the percentage change in price, it's also pretty big, but not as huge, I think. Right? So in the second example, the numerator, the upper part, is bigger than the lower part. So the answer is going to be more than 1, right? So that brings us to the answer to your question. If it's less than 1, ignoring the sign, then we call this type of demand inelastic. If it's more than 1, ignoring the sign, then we call this type of demand elastic. Okay. So let's throw in the numbers, right? In the first example, we're going to have a percentage change. Let's see, if the price goes from 50 to 80, what will be the percentage change? 80 minus 50. The way we calculate percentage change is new value minus the old value, right? Divided by the old value, multiplied by 100%, right? So that's going to give me 60%. Correct me if I'm wrong, I think it's going to be 60%, right? What if I instead told you that, just by chance, the price of rice dropped from 80 to 50? What will be the percentage change? So that will be 50 minus 80. Okay, before going there, let's have a look at the red example. Price also increased. So I want to see the sign. So let's have a look at the quantity now. The quantity has dropped from 120, I'm sorry, to 100. So, no, this is original, this is new. So new minus original, divided by original, times 100%. Here is why I keep talking about ignoring the sign, right? Because in this example, the percentage change in quantity is going to be negative, right? And the whole ratio is also going to be negative, because one of the sides is negative. So if you put this on the number line, we're going to have 0 over here, right? And it doesn't matter which direction you go, up or down the slope of demand curve. The change in price is going to be going in the opposite direction to the change in quantity because demand is downward sloped, yes? So in our case, the denominator is negative. If instead we had a look at an example of the price going down, the numerator would be negative. So one of these would be negative anyway, because demand curve is downward sloped. When price goes up, quantity goes down, or when price goes down, quantity goes up. So our answers are always negative, right? So if I compare to -1, the explanation of what is elastic, what is inelastic demand can be quite confusing, yeah? Because let's say over here the answer is, how much is the answer? Let's call it 20%, just for simplicity. I don't want to do the calculations too much over here.
Minus 1/6.
It's 16%, yes? 1/6 something.
Yeah, minus 1/6.
Negative 16%, so that's a ratio of about a quarter. 15 would be a quarter, right? That's about a quarter. So that's something like negative quarter or so, right? Whereas in that example, this percentage change is something like, call it 63%. Call it 60%. So that's something like, that ratio is, let's say something like 1.1, for example, negative 1.1, right? So here it's getting really confusing because if I say that when elasticity is high, greater than 1, if we look at the numbers, what do you mean by greater than 1? Actually, strictly speaking, mathematically speaking, -1/4 is greater than -1 because it's to the right side, right? So it's really confusing for my part. Really confusing. Right? Right? So here the reaction is greater, elasticity is greater, but strictly speaking, mathematically, that will be really confusing. So looking at different textbooks, looking at different explanations, unfortunately there are different ways books deal with this. Some books just ignore the negative sign. So that's not great mathematically because you just ignore the sign. I don't really like it, but I don't also want to have too much confusion. So anyway, looking at absolute values, you might have studied absolute values in high school, right? So an absolute value is denoted by these kind of straight vertical brackets, right? So let's say an absolute value of any A, right, is A, okay? Or an absolute value of a negative number, let's say we have -6, B, is just going to be B. It's just, absolute value is turning any kind of sign into just a positive sign. Positive into positive or negative into positive, right? So ignoring the negative sign or just looking at the absolute value, right? If this ratio is greater than 1, it's elastic demand. If this ratio is less than 1, it's inelastic demand. So that's one thing I want to talk about. But there's also another thing to mention, another potential confusion over here. Okay, another potential confusion. If I calculate the percentage change for the price rise from 50 to 80, that is a 60% change, right? What if I calculate the percentage change of a price drop from 80 to 50? What do I do here? The new price is 50 minus the original 80 divided by 80 is going to be multiplied by 100%. Is going to be -30 over 80 times 100%. So 3/8 is something like 38%, is it? I'm just guessing, but how much is 3 divided by 80? Wow, cool. I guess pretty close. So it's something like -37.5%, right? What's going on here? You It's the same price range, the same product, right? Even the same demand curve. Nothing has changed, no fashions changing, right? I look at the same section of the demand, this distance between A and B. When I go from A to B, I go up by 60%. When I come down from B to A, I only go down by 38%. What? It's really confusing. Okay? A lot of confusion here, so two sources of confusion. So for that reason, okay, from now on, whenever we talk about elasticities, and there are different kinds of elasticities, we're going to continue next week, okay? From now on, we're going to introduce a new way of calculating percentage changes, okay? So all your exams and everything will have a new way of calculating percentage changes. So when you have to calculate the percentage change from 50 to 80, the answer is not going to be 60. And the answer is not going to be 38 or 37.5. So a new way to calculate percentage change to avoid any sort of confusion like that, where the answer depends on the direction. How come? It's just the same section of the demand curve. So the new way to calculate our percentage changes is going to be, unlike in high school, what we're going to do is take the new minus the original, okay, and the difference is going to be over here. We're going to divide not by original. In high school, we divide by original, right? What we're going to do is we're going to divide by the average of these two. Okay? We're going to do by the of these two, right? The average between the new number and the old number. Because if we want to calculate percentage change, it's a change from something to something. There must be an original number, there must be a new number. That's what I mean when I'm talking about the new number and the old number, right? How do we calculate percentage change? We take the difference between the new and an old, and in the high school we used to divide by the old, right? Now, from now on, whenever we talk about elasticity, we're going to divide by the average of the two, of the new and the old. The average between 50 and 80 is, I think it's 65. So, we have one less chair now in the classroom. It's okay, we still have 70 or something left. Okay, so now with all of this confusion discussed, let's actually find the numbers for these examples, okay? So in the rice example, 80 minus 50 divided by 80 plus 50 over 2, that will give me the average, right? That's the percentage change in price. That should be in the denominator. And in the numerator, I have the percentage change in quantity. Okay, so new minus old divided by the average of new and old, which is 110. Right? So all of that is going to be negative 20 over 1, or negative 2/11. 2/11 over positive 30/65, right? And then if you guys can help me with the calculator. Okay, 2 over 11 is and 30 over 65 is okay, so 8 over 04615 is something like negative 39.4%. No percentages here. Because this is in percent and this is in percent. Percent divided by percent, we have nothing left. So, I think I was moving out of the screen over there. So, our numerator is the percentage change in quantity, our denominator is the percentage change in price, percentages by percentages, percent divided by percent, they cancel out, we don't have anything left. So elasticity is unitless measure. It's a measure without units. Okay. What else do I need to talk about? So, how about the sign for our exams 2 weeks from now? I will try to remember. I prefer not to ignore the negative sign because I guess it's correct mathematically. But I will try to remember to accept both positive and negative numbers as correct. So because some textbooks, they just simply ignore the negative sign, but they show the answers as positive sign. Whichever textbooks you use to review before the exams or whatever, in my class, in my exam, either way will be fine.
Is it possible for us to set up like a review period before the midterm of like everything we've received? Is that okay? It doesn't have to be during class. It can be like another time. I know it would help me a lot.
Right. Let me think. If we talked about it earlier, we could have had this week as a review and next week as the exam, then exam covering only 3 chapters. So if instead we have a review after finishing this chapter, then that pushes the midterm to week 11. That is possible. Is that great? I don't know. I mean, we have flexibility, whatever way we arrange our exams, as long as we have both exams, the university will be fine with that. So that's one possibility. Another possibility is I could post like a bunch of questions, let's say,
Like a questionnaire. Like a questionnaire for the exams?
Yes, like practice questions. Anywhere from like 100 to like 120 questions or so on Moodle. You don't have to look at them, right? You don't have to look at them. But I guess if you look at them, it can be helpful for you. And the exam questions might be quite similar. So I'll just, so what I could do is just maybe like copy paste the test bank from the textbook for you to practice in your own time without postponing the midterm. So that is another possibility as well.
I like that one.
Yeah, it's okay to move the exams around. That's why I moved it to week 10, but push it to 11, I don't know. I prefer to have it in week 10.
Okay.
So I think I can just post a lot of practice questions on Moodle for 4 chapters, and you can have a look at them. Yes. I'll see if there are answers in the test bank. Yes. So, yeah, remind me when we finish the class today, so I remember to post it. Okay. So that's a pretty good question. So that's elasticity. That's how we calculate elasticity. And there are a few examples on Moodle slides. For example, the price of rice increased by 10% and quantity demanded dropped by 5%. How much is price elasticity of demand? Simple question, I'll read it again. These questions are on your Moodle slides. A bit of like practice after we introduce elasticity. Price of rice increased by 10%, quantity demanded decreased by 5%. How much is price elasticity of demand?
10%.
I think it's 0.5.
Oh yeah, half.
I think it's 0.5.
Oh.
I think it's 0.5. Price of chocolate decreased by 20%. Quantity demanded increased by 30%. How much is price elasticity of demand? Price of chocolate dropped by 20%.
20%.
So people buy 30% more, right? 30% more. So how much is price elasticity of demand? 1.5. Yes. And there are a couple of more questions. You can have a look at it when you have time at home. There are only 4 questions, so it's not really much for practice. I'll try to dump a lot of questions on Moodle later. Okay. So, unit 3 measure and using averages to calculate percentages. Discussed all of these. Oh yes, elastic demand, inelastic demand. Let's write it down. If price elasticity of demand is less than absolute value of 1, I guess this is also absolute then it's inelastic demand. And then what is the middle point, right? What if price elasticity of demand is equal to -1? Or in absolute values that's just equal to 1? It's called unit elastic. It's neither elastic nor inelastic. There's a different name for that. It's unit elastic. It's like if there is a border, I'm on the left side of the border, I'm in France. On the right side of the border, I'm in Spain. And if I'm standing on the line, where am I? Right, so there it is. So in the recent couple of examples, with chocolate, elasticity is equal to 1.5, ignoring the negative sign, right? That's elastic demand, right? With rice, where elasticity was with the rice in more recent example, not this. Or either one, yes? I made a mistake over here, right? Not 31.4, it's 0.4.
0.4.
Yes, thanks. Yes.
And that one too.
Huh?
It's 0.16.
Yeah. Oh, well, but this is in percentages. This is okay, right?
Oh.
Because we multiply by 100% here, right? There, 100%, 100%, they cancel down. They don't have that anymore, right? Okay, so covered all of that. So what are we learning from this? Rice is inelastic. Sausage, German sausage is a very particular thing, or chocolate are quite elastic. The demand for them is quite elastic. What's the difference between rice and bread versus German sausages and chocolate? How do you guys think?
Where?
Huh?
Where though?
Where? Okay, what's the difference between rice and German sausages in, let's say, many Asian countries? And what's the difference between, let's say, bread and chocolate in many Western countries where bread is a staple food, right? What is the difference between those? If it's a staple food, you can't really switch to many other things, right? You're already used to have it every time, right? So what can you eat instead of rice, right? Hard to find other things, right? Maybe you can have sweet potatoes, bread, but for people who are already used to it in Asian countries, right? They'll not like to do it for a long time. Or same for bread in many other countries, right? So that's basically how easy is it to find substitutes, right? Right. So That's our next subtopic. Where am I going to put it? Let's put it here. Factors affecting price elasticity of demand. First is closeness of substitutes, right? So that says closeness of substitutes. Basically, how easy is it to find similar things, right? The easier it is to find substitutes, right? The easier it is to find substitutes, the higher is price elasticity of demand, right? And vice versa. And vice versa, right? Meaning the opposite is true as well. It also depends on how broadly you look at the market, or if you can't read what I'm writing, to read it word for word. Also depends on how broadly you define the market. Because over here, this market is very narrow, particularly German sausages. Yes. What if I said instead something like meat? That's all the meat. This is the market for meat. I think it will be much more inelastic, right? Because a lot of people love meat. Okay, they can give up German sausages, no problem, if they can eat pork, or they'll be still happy if they can eat beef instead, or whatever, right? But if you look at the market for meat, numbers will be probably different, but the demand curve probably is going to be more steep.
How broadly you
define the market. Second is proportion of income. I'll just explain it with arrows so that my writing is quick. So the greater is the proportion of income, the greater is price elasticity of demand, and of course vice versa. The lower, the lower. So let me explain. It also, elasticity also depends on how expensive is the product compared to the income that people have. For example, let's look at this marker, and let's have a look at the price of a car. Marker is a very small percentage of someone's income. So if you really need it for your study, even if the price goes up by, I don't know, 300%, that's four times the price. Instead of 10 NT, it becomes 40 NT. Okay, for 40 NT, you're still gonna buy it. You have to do that presentation in classroom, and you're gonna need it, right? So people still gonna buy it. Elasticity is quite low, inelastic, even if percentage changes are quite big, right? But for a car price, right? Say you're planning to get that car because you got a job in Tainan and you got a commute that's like by car it's 1 hour, but by train it's an hour and a half, or like an hour and 20 minutes or something, right? So perhaps you were planning to get that car, but recently prices increased by 25% or something. A quarter of a car price is quite a lot of money. So maybe you're like, I'm just gonna take the train, right? So, proportion of income, how expensive is the product as a proportion of income, and time. time elapsed, time passed. Since the price change. If more time has passed, price elasticity of demand is lower, and vice versa. For example, I don't know, for example, fuel, energy, fuel, gas, petrol. Let's say you have that car of yours, right? And the price of gas, the price of petrol has doubled. Oh my, now it's kind of much more expensive to drive me alone in that big car all the way to Tainan, right? So maybe instead I'm gonna use my car a bit less, gonna carpool with my friends, we take turns who is going to drive. So instead of driving on 5 days a week all the way to Tainan, I'm just gonna drive on 2 days of the week, right? So I'm gonna use less petrol. Or maybe I'm just gonna take the train on many days, right? So I'm gonna use less petrol right now because the prices have doubled. But with time, as time moves on, right, perhaps my income changes, perhaps I just get a smaller car, right? So, or maybe I just get a scooter instead. And if my car is more efficient, it's smaller, it consumes less petrol, I can drive it more frequently, okay? Adjusting to this price change with time, okay? So in the short time, usually in the short time, price elasticity is lower, okay? I can't really adjust quickly, but with time, I can probably adjust. Okay? So the more time we have to adjust, the more is the price elasticity. Well, I mean, so the arrow is incorrect. My explanation is fine, but I put the arrow in the wrong direction. The more time we have to adjust, the more is price elasticity. The more is our possibility to adjust. So perhaps in the very short term, it will take me time to find friends, to carpool. So maybe I still have to drive my car, even in the short term. So in the short term, the demand is not very elastic, but as I have more time to find friends to carpool, as I have more time to get a smaller car, perhaps my consumption will decrease. Okay, so that's another subtopic, factors affecting price elasticity of demand. Should be enough for the first half of the class. Any questions?